Hi, welcome to our next level 3 differentiation video. In this video, we're going to look at the differentiability of functions. A function is considered to be differentiable at a point if we can determine the gradient at that point. We're going to go through a whole lot of examples and features that we are using this graph for to show you when a function cannot be differentiated. It is not differentiable, and therefore we cannot determine a gradient at that point. So let's get started. This is our first point, and this is called an asymptote. You may have come across asymptotes when you looked at hyperbola functions earlier. An asymptote is a line that the function gets close to but will never touch. And because there is no y value when x is -1, we're going to say that it is not differentiable at x is equal to -1 because of the asymptote. All right, let's look at this point, and this point. These all represent a sudden change in the gradient. Now, normally functions go from a positive to negative or negative to positive, and they pass through a zero gradient to make it a turning point or stationary point. They can go from negative to negative. But these points represent sudden changes of gradients, and they're normally created by several things. The first being that it could be a piecewise function. The function on the left of positive 1 is a x squared function, a parabola, and the function on the right of 1 is a square root function. And this is the point where they two meet. Now, the parabola function would have this gradient when x is 1, and the square root would have this function when x is 1. So we're changing from this gradient to this gradient at the same time, and that's not possible. So we say when x is 1, it is not differentiable. The other way these things occur is called the absolute value function. Here's a graph of y equals x. It's a straight line graph. And if I put into the absolute value function, it takes the negative part of the graph and turns it into the positive part. We go straight from a negative gradient into a positive gradient at that point. Straight away, there's no gradient of 0. So it's not differentiable at that point. What about another graph, y equal to x squared minus 2, which is a parabola, but again I've taken an absolute value function to it and taken this negative part of the parabola and turned it into a positive. Well, you can see this point here is a turning point. That's got a 0 gradient, but these points here represent sudden changes in the gradient, and they are not differentiable. So these 2 points are probably piecewise functions, and this point's probably an absolute value function. They all represent a sudden change in gradient, and they are not differentiable at each of those x points. All right, let's move on to this part of the graph, which represents a jump. You can see when x is 6, the value of the function is about 1.3, 1.4. But then it leaps up to a value of 4. The open circle means it is not a value of 4, and it carries on its journey. Because of this jump, it is not differentiable. We can't determine a gradient when x is 6. All right, well, these points represent single points, and we can't have a gradient at a single point because we need a rise and a run, so they are not differentiable at each of those x points. All right, well, these are holes. Holes represent a part of the function. It's not the actual value of the function. They're not the value. This hole here has been created because of the jump. This hole here, well, let's explain probably why this is here. Let's have a quick look at this example and show you it's a straight line graph, even though it looks like it. When we take the top part and factorize it to 2 brackets and cancel out the x minus 2's, we're left with x plus 3, which is a straight line. But because we've got this x minus 2, we can't divide by 0, so 2 minus 2 is 0. So when x is 2, we can't have a value for the function, so we put a hole in. Well, holes are not differentiable. Finally, we have a vertical line, and they're not differentiable because we need a rise and a run. So all these features represent parts of a graph that are not differentiable. Great, thanks for watching.